Hi, it's Miss Lily. So this is the second part of average rate of change. So if you were with me for the last video, we talked about average rate of change as being the same formula as slope. So for some of these problems, I want to look at how it's written in interval notation. -1 to 2 is the interval here. So this is going to be the interval that we want to plug in. So basically, those are the points on our domain. Excuse me. And if you remember, our domain is our x's. So the first thing we want to do is find our range or our y values. So since we have an equation, what we have to do is plug in our domain one at a time to find our range. So if we take and plug in -1 for x here and here, make sure you use order of operations, or make sure if you're using your calculator you put it in parentheses, because you need it to square it before it multiplies by the -1. So make sure you enter it in your calculator correctly, and I got -21. Hopefully you did as well. Alright, so then we're going to look at substituting 2 in. That's their second number in our domain. So we're going to do the same thing, plug it in for our x's here and here. Once we do that, hopefully we get the same answer. If you get -6, now it gives us 2 ordered pairs. Alright, so if you can remember, once we have our 2 ordered pairs, slope is y2 minus y minus y1 over x2 minus x1. Alright, so we have x1, y1, x2, y2. Again, the order in which you do your points doesn't matter. You just have to do them in the same order. I usually start with the second point as y2. Okay, so if I start with the second point as y2, I'm going to have -6 minus -21, which is +21. And then I'm going to have 2 minus -1 or +1, and that gives me 15 over 3. That reduces to 5. So my average rate of change here would be 5. Okay? These are all basically the same. Since this is another quadratic that's cubic, you still just plug it in. Let's do another one real quick and just make sure you're following me. Alright, so -2 is our x, 5 is our x. We're going to take and substitute those one at a time in for the x's in the equation. So to find my y values, or my f of x, which is my y, then I have to substitute that in. So if you plug in -2, I think you get -21 again. Check me, make sure I'm right. And if you plug 5 in, I got -567. Okay? Then I do the exact same thing. -567 minus -2, which, or sorry, -21, which is plus 21. And then I do 5 minus or plus 2. So I'm going to have -546 over 7, and that equals -78, if I did all my math correctly. Okay? Alright, so average rate of change, very similar to slope. Okay? Let's look at a few more examples. These are a little bit harder for some people. Alright, I think my video is working again. Welcome back. Alright, let's see if we can do the average rate of change on the interval 2 to 8. So I'm going to have my x is 2, my other x is 8, and I have to plug it in to find my y value. So if I plug 2 in here, I'm going to have 2 minus 4, which is negative 2, over 2. That's going to reduce to negative 1. Okay? Then I'm going to plug in my 8. 8 minus 4, 4. 4 over 8 is 1/2. Yes, you can have a fraction. Okay? Alright, so average rate of change, my y, minus my other y, and then my x minus my x. So 1/2 plus 1, that becomes 3/2. 8 minus 2 is 6. Okay, that's the same as 6 over 1. I can multiply by the reciprocal and get 3 over 12. And 3 over 12, both are divisible by 3. 3 goes into 3 one time. 3 goes into 12 4 times. So 1/4 is my answer. Okay? Alright, I want to move on to the word problems, but I'm going to go to number 14 very quickly and show you that if you have -1 and 7, and I plug these in, -1 plus 5 is 4, the square root of 4, just leave it as the square root of 4, it's fine. Square root of 4 is 2. If you want to reduce it to 2, go ahead and reduce it, but I'm going to show you that it doesn't matter in this case. And then 7 plus 5 is 12, square root of 12. Okay? So you're going to just plug in exactly like we have been. Square root of 12 minus square root of 4. And then I'm going to do 7 minus -1. So that's going to be about, I'm going to use the squiggly lines because it's approximately 1.464, something like that. And then 7 plus 1 is 8. So this time we're going to get a slope that is about 0.18. So that one's not exact, but not too bad. Alright, let's get to the word problems. Alright, application problems are fun because you've got to figure out what it's talking about. Hopefully it makes real sense to you for an actual real-life type of problem. Alright, so a company's total cost in dollars to manufacture X units is given by this function. Find the average rate of change, so we're doing the exact same thing, of the total cost of the first 200 units. So it doesn't give us a set, but we want the first 200 units. If you think about making something, you can't have negative numbers. So the first 200 would start at 0 and include 200. So we can say that's our X value. And if I have X at 0 and X at 200, then I can plug 0 in, and you can pause this and type it in your calculator. You should get 1200. If I take 200 and plug it in for X, you're going to get 11,200. Okay, so we're going to do the exact same thing we've been doing. Y2 minus Y1 over x2 minus x1. Okay? If I type that in my calculator, I'm going to reduce that to 10,000 over 200, and that reduces to $50 per unit. Alright, so again, we were just finding the average rate of change for the total cost of the first 200 units. So the first 200, that gave us the hint, 0 to 200. Alright, we have one more word problem to look at here. It's a little bit more work. So I'm going to clear this and see if I can move up. Alright. And having problems again. Alright guys, I think I am back in business. Still trying to figure out this thing. My computer wants to go from computer mode back and forth to tablet mode, so bear with me. Alright, 16. A ball is thrown straight upwards so that its height in feet is given by the equation h of t equals negative 16t squared plus 80t, where t is time in seconds. Find the average rate of change. Again, we're doing the same thing. For a ball that's thrown from it reaches its maximum height until it reaches the ground. Okay? So, this is a quadratic. You got to think back to Math 2. Last year you found the maximum height of a quadratic by doing negative b over 2a. Okay? So, for this equation, negative b would be negative 80 over 2 times your a value is negative 16. Reduce that, I get negative 80 over negative 32, which is about 2.5 seconds. Alright, so that's my x. That's the maximum height. Maximum height of the ball right here. Alright, then I want to see when it reaches the ground. So the ground is going to represent your zeros. So again, remember back to Math 2, negative 16t squared plus 80t equals 0. Set it equal to 0. Find your greatest common factor. Pull out your greatest common factor and you have another factor left. Set each one equal to 0. And solve. Alright, so it's leaving the ground at 0 seconds. It's going to hit the ground at 5 seconds. So the interval we want is from its maximum height, which is 2.5, to when it reaches the ground again, which is 5. So again, we have to take those x values and plug it into the equation for t and find h of t, which in this case is our y value. Okay, if you do that, you plug in 2.5 here, you're going to get 100, and you plug in 5 and you're going to get 0. So y2 minus y1